So today's topic on the brief introduction about the nanoscale effect, nanoparticles, nano-pesticides, nano-fertilizers, and the nanosensors. First one, we can see the nanoscale effects. The nanoscale, which will approximately measure the particle size, ranges from 1 to 100 nanometer. The effects of the nanoscale are the depends on the two important principal factors which will be there. It is to differ the significant of the material, that is in increase relative surface area and the quantum effects. These are the two effects are which will be uh, uh, shows the effects of the nanoscale material, especially in surface tension. As per the conventional materials, the nanoscale material which will be more surface area or surface tension than the conventional material, which will helps to hold the particles or the material tightly to the soil particles, and it will be if give the quantum effects. Then second, that is the morphology aspect ratio or the size of the nanoparticle. Then hydrophobicity, solubility, release of the toxic specimen, the absorption during the synthesis, release reactive oxygen species, that is ROS, capacity to produce the ROS, structure or composition, competitive binding sites with the receptor and dispersion are important properties of nanoparticles. The nanoparticles which will be uh, important, that is the morphology, which will the size or ratio of the particle. Then hydrophobicity, that is absorption of the water molecule into the particle. Then solubility regarding this release of these specific contaminants or the absorption process, and also the reactive oxygen species. This is also important for the uh, to give this or supply the nutrients. Then also the capacity to produce the ROS, and then structure composition of the nanoscale particles, also the binding sites which were the applied into the soil, which will bind into the clay particles or the soil particles, which will be depends on the receptor and the dispersion. These are the important properties of the nanoscale particles. Then when the particle size of the solid material are visible scale are compared to that of the regular optical microscopes, which will be differ in the difference in the properties of the particles. As we know, the size of the particle is the solid matter which will be visible scale, which are really seen on the optical microscope, which can categorize the difference properties of the particle. Then but when particles are created with dimensions, that is approximate scale, that is 1 to 100 nanometer, the material properties changes significantly from those at larger scales. These are the size scales which show the quantum effects regarding the behavior and properties of the particles. The properties of material is also depends on the size dependent in the scale range, that is 1 to 100 nanometer. Then particle size made with the nanoscale, that is approximately 1 to 100 nanometer, such as the melting points, fluorescence, electrical conductivity, magnetic permeability, and chemical reactivity changes in the function of size of particle. In short, the summary of the nanoscale effect, the effects of nanoscale, it depends on the two important principles, that is in surface tension or the surface area, and the quantum effects. As the surface area of the particle is increases, then increases their holding capacity or can be hold tightly into the soil particles, and will be gives the quantum effects. Or also the nanoscale effects of the particle is depends on its ratio, size, shape, or the hydrophobicity, or the absorption capacity or release of the oxygen, structure, composition, or binding sites. And also this solid matter which will be seen by the regular optical microscope, and these particles which are be created or produced or made with the dimensions of 1 to 100 nanometer, and the material properties can be changes accordingly. And these effects which will be depends on the behavior and properties of the particles, and the properties of particles which will be mainly depends on the size and the scale range, that is 1 to 100 nanometer, and the size of particle is made on the nanoscale range, which will be the major property, that is melting point, fluorescence, electrical conductivity, magnetic permeability, chemical reactivity changes as a function of the size of the particle. This is the nanoscale effects. Then also the nanoscale golds. These are the nanometals, that is gold, palladium, platinum, silver, which will be unique property that occurs in the nanoscale. The nanoscale gold particle are not only in the yellow color, but with which will be familiar. The nanoscale gold can appear red or purple. At the nanoscale, most of the motion of the gold's electron is confined, because this is a movement which is restricted. Gold nanoparticles react with different high compared to the larger scale gold particles. The size and optical properties of these nanoscale gold particles, which will be accumulate in the for the imaging and targeting laser destruction. The nanoscale material have the far large scale area than the masses of the larger scale material. And then also surface area per mass of the material also increases. Greater amount of the material can come in contact with the surrounding. In short, that is nanoscale golds, which will you have the unique property according the nanoscale, and also they are not in golden in color, which will be appear red or purple. Then nanoscale, which will be go motion of the gold electron, and this movement of this nano gold scale particles will be depends on the or will be differ with the light compared with the scale of the gold particles. The size of the and optical properties of this nanoscale gold particle, which will be accumulate or depends on their image and the target laser destruction. This is a detailed information regarding the nanoscale metals, that is especially gold. Next one, the nanoparticle. The nanoparticle is ultrafine unit which will be dimension measured in the nanometers. That is 1 nanometer is equal to 10 raised to minus 9 meter. The nanoparticle or ultrafine particle is usually defined as the particle of matter that is between 1 to 100 nanometers in diameter. The term sometimes used larger particles up to 500 nanometer, or the fibers and tubes that are less than 100 nanometers in only one directions. Then nanoparticles are usually distinguished from the fine particle sizes between 100 and the 2500 nanometer, and the coarse particle ranges from 2500 to 10,000 nanometers. They are subclasses of the colloidal particles, usually we range from 1 to 1000 nanometer. The metal particles smaller than 1 nanometer are usually called as the atom clusters instead, being much smaller than the wavelengths of visual light, that is 400 to 700 nanometer. Nanoparticles cannot be seen in the optical microscopes, requiring use of the electron microscope. With the help of electron microscope, we have to evaluate or assess the size of nanoparticles. Then most of the nanoparticles will be easily pass through the filters, such as common ceramic candles. So as the separation from the liquid requires some nanofiltration technique, which will be used for only the filtration or to remove the impurities present, especially in the water purification. The nanofiltration technique can be used. This same technique will be used for the particles which will filter easily. This is the introduction or the detailed information about the nanoparticles. Then also the nanoparticle properties, which will also depends on their diameter between zero point 0.5 to zero point 0.6 nanometer large fractions. Then also sometimes of the physical, chemical, biological, geological properties of nanoparticles will be evaluated. Then also the atomic number or the molecular structures of the particle. Then also the nanoparticles are important components of the atmospheric pollution, as well as it is used for the industrial products like paints, plastics, metals, ceramics, and magnetic articles. Then production of nanoparticle with specific properties is an important branch of the nanotechnology. The next one, we can see the concept or detailed information regarding nanopesticides. The nanopesticides are plant protection products, represent an emerging technological development that in relation to pesticide use, which will be range of the benefits, including the increased efficacy, durability, and reduction in the amount of the active ingredient that need to be used. Means in case of the nanotechnology, the nanopesticides, which will be emerging technology, which will be whatever the pesticides are used, which will give the much of the benefits will especially to increase the efficacy, their durability, and their reduction in the use of actually amount of use of the active ingredients. These are the basic benefits which will be obtained through the use of the nanopesticides. The number of formulation types have been suggested, including the emulsions, non-emulsions, nanocapsules with polymers or with the product containing the metal oxides, nanoscales are the different types of formulations which will be included in nanopesticides, that is in polymers coating or the emulsion coating or the metal coating, metal oxide coating, clays coating. These are the nanopesticides are prepared by means of this type of formulations. Then these products which will different stages in the production development cycle can be used to improve their efficacy as well as the existing active ingredients or the to enhance their environmental safety profile or the both. The main aim of or objective of the manufacture or preparation of the nanopesticide, that is to increase their efficiency or efficacy, durability, stability, as well as to reduce their release to the in environmental or to avoid the environmental quality to maintain this environmental quality. This is the main aim or objective of these nanopesticides. The majority of nanopesticides described as nano in the literature greatly exceed to the 100 nanometer size boundary that has been recommended for regulatory purpose. The most important definition as based on the size alone would exclude many recent so-called nano formulations, and the other hand include products that have been marketed for decades without posing particular problems. The nano formulations or the nanopesticides, which will be the important definitions today. Now, uh, presently, they use the terms that is nano formulations. Then, how to prepare the nanopesticide? That is different techniques which will be included. That is nano emulsion, nano suspension, nano encapsulation, and then nanoparticles. We can see the example from this diagram. That is nano emulsions which will be coating of this particle or the material with the help of different types of the emulsions, that is polymer or wax coating or the sulfur coating emulsions or the different types of suspensions also used, and in that nano capsule are also covered with this particle, and afterwards the metal nanoparticles, especially nanometals, platinum, silver or gold, which will be used in this coating of these particles, which will finally produce the nanopesticides. Then nanopesticide formulations, especially in the any formula that is initially includes the elements in the nanometer size range, and the this is the novel properties associated with these all small size ranges, which will seen earlier side, that is nano emulsions, nano capsule. That is first step, that is nano emulsions, which will coated with powder form or wax coating form or the polymers or the suspensions, which will be different types of emulsion, that is hydrogel or the zeolites, which we used to coating with the particles. Then after that the capsules which will be coated. Inside the capsule there will be the sensor which will give the detailed information regarding the field conditions or the microclimatic conditions in the field, and then finally metal coating with the help of the platinum, gold or silver is used for the development of nanopesticides. The nanopesticides can consist of the polymers and the metal oxides or the metal nanoparticles, which will be in various forms. The aim of nano formulations in pesticide are to increase their apparent solubility of poorly soluble active ingredients. That is first aim of the for nano formulation in pesticide or nanopesticide, that is to increase their solubility level, then release the active ingredient in slow or targeted manner, and protecting the active ingredient against the premature degradation. That is to save the active ingredient and as well as to release the active ingredient in the slow in a specific target manner. The nano formulation can be expected to have the significant impact of the fate of the active ingredients. introduce new ingredients whose environmental fate is poorly understood, that is nano silver. Then currently level of knowledge does not appear to allow the fair assessment of the advantage and disadvantage, which result in the use of some nano pesticide. This nano formulation can be expected, which will have the significant impact on the fate of active ingredient. Then also the major one, the introduction new ingredient to the environment fate. And then finally, that is advantage and disadvantage assessment will be helped by the means of nano formulation. Then next one, nano-fertilizers. Nano-fertilizers are the modified fertilizers synthesized by chemical, physical, or biological methods using the nanotechnology to improve the attributes or the composition, which will be enhance the productivity of the crops. The nano-fertilizers are made up of nano-sized nitrogen molecule coating with the polymers, coating with the biosensor, and which release the particles when the soil is needed. As we know, the nano-fertilizers, the particles which will be modified or by encapsulation or by coating either with the polymers, emulsions, or the hydrogens or the zeolites, which will be improve their nutrient use efficiency as well as yield or productivity of the crops. Then also the nanofertilizers are defined as the study as the way to increase the nutrient efficiency as well as improve plant nutrition compared with the conventional fertilizer or traditional fertilizers. The nanofertilizer refers to the products that deliver the nutrients to the crops in three ways. That is, the nutrient can encapsulated into the nanomaterials such as nanotubes and the nanoporous material. The nanotubes are the made up of the carbon, which is or built up with the carbon, which is granular structure or tubular structure, which will be helps to assess the biochemical changes or the uh, mostly used for the filtration of water or the improving the nutrient stability. Then coating with the thin protective polymer film. This is also used for the preparation or manufacture of nanofertilizer. That is, polymer films are used and deliver a particle or the emulsions of non-scale dimensions. No, sorry, nanoscale dimensions. The dimensions will ranges from 1 to 100 nanometer. This is a meaning or concept or definition of the nanofertilizers. As the nanofertilizer is any product that is made with the nanoparticle or use of the technology, that is especially nanotechnology, to improve the nutrient efficiency. The main aim of nanofertilizer is to coating with the particle or the material with the help of hydrogen zeolites or the polymers or the different nanoscale metals, which will be platinum, palladium, silver, or gold, which will helps to convert the fertilizers that is in fast release of fertilizers to slow release, as the rate of slow release or availability of the fertilizers will be helps to increase their efficiency. Then provide the nutrients as per the need of soil or as per the need of crop. The nanofertilizers are the emerging of promising alternative to chemical fertilizers in agriculture. The nanofertilizers may exert a positive role through the slow nutrient release and the increase the nutrient use efficiency. This is the main positive role of nanofertilizer, that is to increase the nutrient use efficiency and as well as the convert of the fertilizer into slow release. The nanofertilizers have also shown to increase the abiotic trace tolerance in several cases. The nanofertilizers are the smart way to release the plant nutrients gradually and in controlled manner. They reduce the quantity of fertilizer used, controlling eutrophication and pollution of the water resources. This is also the purpose of nano fertilizer, that is especially eutrophication, that is release a large amount of fertilizers into the water bodies. Then especially the different gases are emitted, especially phosphorus, nitrogen. The concentration has increased in the water bodies, that will be reduced by use of the nanotechnology or nanofertilizers. The nanofertilizers have the main use or the benefits, which will be increase the efficiency of fertilizer. They increase the uptake of the nutrients from the soil. Then extend the duration of nutrient supply as a supply of fertilizer, that is slow release rate. Reduce losses of fertilizer or loss rate of fertilizers nutrients in the soil by leaking. This is a major four important role of the nanofertilizer. That is, first, to increase efficiency, that is to increase uptake, then to reduce the rate of supply, that is acts as a slow release fertilizer, then reduce the rate of fertilizer nutrients, that is losses should be reduced by the way of use of the nano fertilizers. The next one, the three classes of nano fertilizer has been proposed, that nanoscale fertilizer, nanoscale additives, nanoscale coating, nanomaterials. Coating should be there in nano membrane, or the different nanoscale materials will be used in the nanoscale fertilizer, where the for particles which contain nutrients, with the additives which will traditional fertilizers with then nanoscale additives, traditional fertilizer coating with these nanoparticles. These are the three classes of nanofertilizers. The nanomaterials coating, such as the nanomembranes, may slow the release of nutrients, and the use of nanotechnology for fertilizer is still important, because of this already has the applied in the medical and engineering applications. Another promising application of nanotechnology is the encapsulation of the beneficial microorganisms that can improve the plant root health. You can see this diagram showing the systematic potential smart fertilizer. As you know, the smart fertilizers means the fertilizers which will be uh, coated with these zeolites, which will be a naturally occurring material, that is honeycomb like structure, which will be increase their efficiency, as well as improve the quality of soil, as well as the microbial activity, then water holding capacity, improve water nutrient uptake, then maintain the environmental quality, as well as plant productivity and the soil health. This is the detailed information regarding these nanoscale fertilizer inputs applied. Then will get changes, that is in the nanoscale fertilizer into the slow release of the nutrients. Then finally the bioformulations will be reduce the nutrient volatilization. Smart fertilizer they are converted into the smart, and then so finally reduce this leaching of the nutrients. This is the detailed information regarding the potential power of the smart fertilizer, as the nutrients can convert it into slow release, and then also ultimately increases their efficiency, and the reduce the loss of nutrient through leaching, volatilize, or the denitrification. Then ultimately overcome the beneficial effects, that is environmental quality, now improve nutrient uptake, improve water holding capacity, improve soil quality, increase microbial activity, plant productivity, and the health of the soil. Next one we can see, this includes the various bacteria or fungi that enhance the availability of nitrogen, phosphorus, potassium in the root zone. The development of the biosensor. The biosensors means the sensors which will be developed or in the measured in the scale range of 1 to 100 nanometer, which is used for evaluating the biological or the biochemical activities with the help of these nanobiosensors to react with the specific root exudates is also being explored by the entry of the roots will be the different root hairs, rhizomes, rhizodermis ruptures, then foliar entry through the cuticle, stomata, hydothodes, lenticles, and ons. This will the potential entry of points of the nanoparticles into the plants, the xylem or the phloem. These are the detailed information of these uh, nanomaterial entry points. Then examples of potential nanofertilizer design, especially from this source, are given by Manjunatha and his co-worker 2016. That is, first one, slow release. The nanofertilizer acts as a slow release, which will be encapsulated with the uh, polymers, emulsions, or the hydrogels or zeolites, which will release the nutrients slowly in a specific period of time. Quick release, the nanoparticles cell breaks upon the contact with the surface. Then specific release, cell breaks open when it encounters with the specific chemical. Moisture release, when the nanoparticle degrade or releases nutrients in the presence of water. Heat release, that is nanoparticle releases nutrient when the temperature exceeds at a set of points. Means slow release, that is will be releases nutrients slowly. Peak release, that is when the cell of nanoparticle break upon the contact with the surface. It may be the leaf or the soil. When the specific release cell breaks open when it encounter with the specific chemical. Moisture release, when the nanoparticle releases nutrient in the presence of water or moisture. Heat release, when the nanoparticle releases nutrient when the temperature exceeds as the set point. pH release, when the nanoparticles only degrades or releases the specified acid or alkaline conditions. Ultrasound release, the nanoparticle ruptured by the external ultrasound frequency. And finally, magnetic release, that is nanoparticles ruptures when they exposed to the magnetic field. These are the examples of potential nanofertilizers design, especially these are obtained from Manjunatha ISCO work 2016. The nanofertilizers have the plus and minus points, that is merits and demerits will be there. The merits are the slow or controlled delivery of nutrients, reduce loss of nutrients, increase the bioavailability of nutrients, synthesize according to the objectives, that is gives highly nutrient efficient crop. But in the other hand, the high reactivity and variability, environmental impact, safety concerns for the farm worker, safety concerns for the consumers, and finally, at no cost for the human health and the environment. Then kinds of nanofertilizers. There are different kinds of nanofertilizers are used as foliar as well as the soil applications, which will be concerned with the environment as they overcome with the biotic or biotic interactions. There are the different nanofertilizers, that is nitrogen fertilizer, potash fertilizer, zinc nanofertilizer, nanoporous zeolite, nanoherbicide, nanopesticide. Others are clay zeolite, inorganic metals, organic molecules seen in the photographs, that is in the fluoricon, then nano zinc, then nano bore, that is boron, which will be available in the market. Then nano fertilizer for precision and sustainable agriculture. Here we can see the different benefits of nano fertilizer, especially for the precision and sustainable agriculture. As you know, the productivity of crops as well as land is low recently. Nowadays it will be decreases the continuous the productivity as well as trace and disease insensitives, nutritional deficiencies are there in the this is the conventional agriculture uh, systems. But in organic agriculture there is low production, then nutritive food, biofertilizer may cause pathogenic sign. But in the bulk fertilizer mediated agriculture, that is the high-tech agriculture where the high production rate, bioaccumulation of harmful fertilizer byproducts, affects natural resource, decrease nutritional quality. But in case of the nano-fertilizer mediated agriculture, which will be increase the production, more nutritious food without toxic effects, where the natural resource, make the production level in a sustainable way. On other hand, in the conventional agriculture, poor biological, especially soil biological health, low native nutrients mobilization, low microbial activity. But in organic agriculture, improve soil biological health, bulk fertilizer mediated agriculture, where the demolish the soil biological health, eutrophication, low microbial diversity. Eutrophication, that is release of nutrients directly to the plant bodies or the toxic elements or the elements. And in case of nano fertilizer mediated agriculture, there will be increase the or enhance the soil biological health, more microbial activity, enhance native nutrient mobilization, reduce the demand of fertilizer. This is the difference between how the nano fertilizers are more beneficial in sustainable as well as precision agriculture over the conventional organic and bulk fertilizer mediated agriculture. Next one, you can see the difference between nano fertilizers and the conventional fertilizers. The properties, first point, that is the solubility and dispersion of mineral micronutrients. In case of the nano fertilizer, improve the solubility and dispersion of insoluble nutrients in the soil. Then conventional fertilizers have the less bioavailability to plants due to larger particle size. The nutrient uptake, second point, nutrient uptake efficiency in nanofertilizers visibly increase the fertilizer efficiency and as well as uptake ratio of the soil nutrients in crop production as they save the fertilizer resource. But in case of the conventional fertilizer, the bulk composite is not available for root, then it helps to decreases their efficiency. Then third point, that is control release modes. In case of nanofertilizers, have the release rate and the release pattern of the nutrients for water soluble fertilizer might be preciously controlled through the encapsulation of the particle. And in case of the conventional fertilizers, excess release of fertilizer may produce toxicity and also may sometimes destroy ecological balance of the soil. Fourth point, that is in the difference, that is effective duration of nutrient release. The nanofertilizers can extend effective duration of nutrient supply of fertilizer into the soil, but in case of the conventional fertilizer used by the plant at the time of delivery and the rest is converted into the soluble salts. The loss of fertilizer nutrients in nano fertilizers, there will be reduced the loss rate of fertilizer nutrient into the soil by leaching or a leaking. But in case of conventional fertilizer, the high loss rate of nutrients by leaching, runoff, or the drifts during the spraying. This is the detailed difference between nano fertilizers and the conventional fertilizers. Then you can see the general advantages of the nano fertilizers, that is nano coating and nanotechnology can helps in numerous way to reduce the cost and increase the productivity around the farm. By way of use of the nano fertilizers, you have to increase their cost of inputs as well as increase their productivity, especially farm productivity. Then also second, improvement in the soil aggregation. Soil aggregation means binding of the secondary, primary particles, soil particles visibly bind strongly. If the soil aggregate stability is uh, stronger or it will be better, then will be the soils can resist the erosion or the loss of uh, soil through the runoff. Then moisture retention capacity also improved with the help of nanofertilizer as well as organic carbon buildup. The yield per hectare is also much higher than the conventional fertilizers, then also giving higher returns to the farmers and it helps to increase the nutrient use efficiency of the farm and finally reduce the environmental impact. These are the advantages of nanofertilizers. Then disadvantages of these nanofertilizers as the problems persists towards the environment sometimes, and then nanoparticles are toxic when they entering into human body has the some disadvantages. Then modes of the nanofertilizer application: in vitro method, in vivo method. In vitro, that is aeroponics, hydroponics. In vivo method, that is soil application, foliar application. These are the different ways or methods of nanofertilizer application. Then the next point, that is important point, how the nanofertilizers are more beneficial as compared to the chemical fertilizers. As we know, the three times increase in nutrient use efficiency, 80 to 100 times less requirement to chemical fertilizers, 10 times more stress tolerant by the crops, complete by source biosource, so eco-friendly, more nutrient mobilization by the plants, 17 to 54% improvement in the crop yield, improvement in soil aggregation, moisture retention, carbon buildup, improve water filtration, infiltration and retention, improve value of fertilizers, improve better plant growth, improve long-term soil quality, reduce loss of nutrients in the soil, increase farm productivity, improve solubility of insoluble nutrients, increase nutrient uptake efficiency, reduce loss of fertilizer nutrients, reduce dose or quantity of nutrient, and control slow delivery, and improve the soil fertility as well as soil productivity. These are the more beneficial effects or beneficial ways of these nano fertilizers over the chemical fertilizers. Next one, this is the important chapter. Today's we have seen this is a brief introduction about the nanoparticles, nano-pesticides, nano-fertilizers, and then how the nano-fertilizers are beneficial. Thank you.